How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at molecular shapes and molecular polarity practice problems. So let's take a look at PCl3. If we add up all the valence electrons, we see there are 26 valence electrons to place, which means we're going to get a Lewis structure that looks like this. All right, I've omitted the octet around the chlorines because, quite frankly, I'm lazy and don't feel like drawing all that. So once I have this shape, the electronic geometry, well, there's 4 domains, so it's going to be a tetrahedral electronic domain. Because we have one unshared pair, one non-bonding domain, the molecular geometry is going to be trigonal pyramidal. And if we are trying to figure out the polarity, well, you can see that there is one line of symmetry in that Lewis structure, which tells us that it will be a polar molecule. Right? We're going to have a slightly negative end where all those electrons are, and we're going to have a slightly positive end on the other side. All right, NH3, when we do the math, we have 8 valence electrons, and that means we're going to get a Lewis structure that is going to look like this. So it looks a lot like PCl3. The electronic geometry is going to be tetrahedral because we have 4 electron domains, but the molecular geometry is going to be trigonal pyramidal because of this unshared pair of electrons. Same kind of thing with the polarity. We have one line of symmetry for the NH3 molecule, which means we have a polar molecule. HCl, we have a total of 8 valence electrons, and it's going to just kind of be like this, right? And then we got the unshared pairs of electrons. Well, in chlorine, the electronic geometry here is going to be linear. Well, it depends on what you're talking about. If we're saying chlorine is our central atom, then the electronic geometry would be tetrahedral because it has 4 domains, 3 of them are non-bonding. The molecular geometry will be linear, and the polarity will be polar because we have one line of symmetry in that Lewis structure. All right, BCl3, we have a total of 24 valence electrons to place. So when we put B in the center and we give the chlorines and we finish the chlorines octets, which I'm going to kind of be lazy again and not draw, but they're there. What is the electronic geometry? Well, it's trigonal planar. It is a flat molecule in a triangular shape, and the molecular geometry is exactly the same because there are no non-bonding domains. The polarity for this is going to be non-polar because you can see we have more than one line of symmetry in this Lewis structure, which makes it a non-polar molecule. All right, H2O, we have a total of 8 valence electrons, and the molecule looks like this. Finish the octet around oxygen. Electronic geometry, well, there's 4 domains, so that makes it tetrahedral. But the molecular geometry, because we have these 2 non-bonding domains, is going to be bent. The polarity is going to be polar because there's only one line of symmetry in the Lewis structure, so there you go. TeCl4. If we do the math, we end up with a total of 34 valence electrons. So when we go to draw the Lewis structure, again, I'm going to omit the octet around the chlorines, just simply because I'm lazy. And then we have to put a lone pair around Te. So electronic geometry, well, there's 5 electronic domains, which means that it is going to be trigonal bipyramidal. But the molecular geometry, because we have this unshared pair of electrons, is going to be seesaw, my personal favorite shape, because seesaws are fun. And the polarity is going to be polar, right? This unshared pair of electrons makes it a asymmetric distribution of charge. Only one line of symmetry means we have a polar molecule. All right, CCl4. So you can flip the pages. All right, we have a total of 32 valence electrons. So we put carbon in the center. We draw the chlorines around the carbon. Again, I'm not going to finish drawing the octets because I'm lazy, but there you go. So the electronic geometry around carbon, 4 domains, tells us it's tetrahedral. The molecular geometry, because we don't have any unshared pairs of electrons, is exactly the same. It's also tetrahedral. The polarity is going to be non-polar because we have multiple lines of symmetry. So it's a non-polar molecule. It's really symmetrical, so there's no uneven distribution of charge. SF6, we have a total of 48 valence electrons. So when we put sulfur in the middle and we draw the 6 fluorines all around it, and we finish the octets for them, we've placed all of our electrons, right? So the electronic domain geometry with 6 electronic domains is going to be octahedral. And because there are no unshared pairs of electrons, the molecular geometry is the same. It's also octahedral. The polarity is going to be non-polar because it's a perfectly symmetrical molecule. So there's not going to be one end that's positive and one end that's negative. All right, XeF4 going to have a total of 36 valence electrons that we got to place. So Xe with the 4 Fs. Let's see what happens. I finished the octets. I've placed 32 of my electrons, so now I have to place 4 more around that central atom. So that's my Lewis structure. Again, I'm lazy, so I didn't draw all the octet around the fluorines, but the electronic geometry with 6 domains is going to be octahedral. Now, if that shape has 2 unshared pairs of electrons, the molecular geometry is going to become square planar. It's going to be a flat molecule. And its polarity is going to be non-polar. Right? You can see in the Lewis structure, it's got multiple lines of symmetry. So there's not going to be a positive end and a negative end. It's non-polar. All right, SBF5 has a total of 40 valence electrons. So when I draw the Lewis structure and I finish the octet for all the fluorines, I will have placed all of the available electrons, which means my electronic geometry with 5 domains is going to be trigonal, bipyramidal, and the molecular geometry is going to be exactly the same because there's no unshared pairs of electrons. So the polarity on this is going to be non-polar, right? We have a very symmetrical molecule. CH4 has a total of 8 valence electrons, so it's carbon making 4 bonds to 4 different hydrogens. There we go. The electronic domain geometry with 4 domains is tetrahedral. And because there's no unshared pairs of electrons, its molecular geometry is also tetrahedral, and its polarity is non-polar because there's multiple lines of symmetry, making it a non-polar molecule. All right, Cl2 has a total of 14 valence electrons, and it's just going to be chlorine bonded to another chlorine. And I could finish the octet around these chlorines. Electronic geometry, well, there's 4 domains, so it's going to be tetrahedral. But because 3 of those 4 are unshared pairs of electrons, we end up with just a linear molecular geometry and a non-polar molecule because we got multiple lines of symmetry. It's a really symmetrical molecule. Also, because it's Cl2, we got a non-polar bond. So it's not like there's even going to be any uneven distribution of charge. ASH3 has a total of 8 valence electrons. So when we put A as, I could draw that neater. Put A, S in the middle. I draw my 3 hydrogens and bond to them. I will have placed 6 electrons. So 2 more got to go on that AS in the middle. Which means its electronic geometry is going to be tetrahedral because there's 4 domains. Its molecular geometry is going to be trigonal pyramidal because of that unshared pair of electrons, which makes the polarity polar. There's only 1 line of symmetry in that Lewis structure. It's a polar molecule. These electrons are very negative, so we're going to have a negative pole up here, which means we're going to have like a positive pole down here. That's the polar molecule. BeCl2 has a total of 16 valence electrons. So I put Be in the middle. I make the 2 bonds to the chlorines. I finish the octets around the chlorines, and I will have placed all 16 of my valence electrons. So if we're talking about the geometry around Be, well, 2 domains makes it linear. No unshared pairs of electrons around Be means it's also linear. And the polarity would be non-polar, right? Because we got multiple lines of symmetry in that Lewis structure. Tells us it's a non-polar molecule. The charge is symmetrically distributed. All All right, SEF4 has a total of 34 valence electrons, which means we put Se in the middle. We have the 4 fluorines. We finish the octet for the fluorines, which I'm going to omit because I'm lazy. And then we have 2 more valence electrons to place on the Se. 5 domains tells us that the electronic geometry is trigonal bipyramidal. Because it has 1 unshared pair of electrons, that tells me that the molecular geometry is going to be seesaw, and the polarity is going to be polar. All right, NCl3. So this will have a total of 26 valence electrons. I put nitrogen here. I bond to the 3 chlorines. I finish the octet on the chlorines, which I'm going to omit showing. And then that's 24 of the 26. So I got 2 more electrons going on that nitrogen. 4 domains around the nitrogen tells me that it is a tetrahedral electronic geometry because we have 1 lone pair of electrons. The molecular geometry is going to be trigonal pyramidal, and its polarity is going to be polar, right? We have 1 line of symmetry. Those electrons up here are really negative. We have a negative end, which means we're going to have a more positive end on the other end. SiCl4 has a total of 32 valence electrons. So I put Si in the middle. I make the 4 bonds to the chlorines. I finish the octet on the chlorines, which I'm going to omit showing, which is now I've done all 32 of my valence electrons. So electronic geometry around Si is going to be tetrahedral. The molecular geometry is the same because there's no unshared pairs of electrons. We have a very symmetrical molecule, so it is a nonpolar molecule. All right, I2 has a total of 14 valence electrons, so I put iodine bonded to the other iodine. I finish the octet around them. And then when I do that, I will have placed all 14 of my valence electrons. The electronic geometry around either one of them is going to be tetrahedral because there's 4 domains. 3 of them are non-bonding, so the molecular geometry is going to be linear, and the polarity is going to be non-polar because we have multiple lines of symmetry. All right, I hope you found that helpful. See you in class. Okay, bye.